Good day everyone. We discussed about PFS, GAM, SGAM pages and allocation contention on our last video. We will check PFS, GAM, SGAM pages using DBCC page command on this particular video. Let's get started. Let's first discuss about PFS, GAM and SGAM page as a recap before moving on to the actual demo. So what is a PFS page? Page free space page. Pfs page maintains information on how much free space on each page is available. A Pfs page occurs once in 8088 pages. SQL Server will attempt to place a Pfs page on the first page of every Pfs interval. The only time a Pfs page is not the first page in its interval is in the first interval for a data file. GAM page, Global Allocation Map page. In the GAM pages, which extents are allocated and which are not allocated information is basically maintained. GAM page will be the second page in the data file. Next GAM page is placed at 511230, that is 5,11,230th page after first GAM page or the GAM interval. SGAM page, Shared Global Allocation Map page. In the SGAMs page, which extents are used as mixed extent information is maintained. SGAM page will be the third page. Next SGAM page is placed at 511230, that is 5,11,230th page after the first SGAM page. Moving on, let's look at the SSMS and then try executing the DBCC page command. So DBCC traceon 3604 would be the first command to execute. Trace flag 3604 is basically going to print the required output in the query window. And this is going to be a session level trace flag, at least for this demo. Before proceeding with the DBCC page command, let me put in a disclaimer. DBCC page is an undocumented command. Never run this on a customer environment. I'm doing this for learning purpose, and importantly, this is a lab machine. So this lab machine will kind of be destroyed after the demo. So as far as the DBCC page command is concerned, it has got 4 parameters. The first parameter is your database name. Second one is your file number. Third one is your page number, and then the fourth one is related to the print output. So we are going to use number 3 here as far as the print output is concerned, as it is going to give us more details as far as the pages are concerned. So moving on, let me first execute this particular command on a database called JB_common_query_tuning_db, and the file number for this DB used here is 1, and then the page number 1 will be used, which is our PFS page, and then the print output will be 3 here that will be utilized. So executing this query. The first thing that I'll be looking at is the m_type. Basically, for any PFS page, this m_type will be 11. So moving on, what we can see is like the output basically shows us like it starts with a page number of 0, and as we know, like each PFS page holds the information of 8088 pages. It starts with page number 0, and let's look at like what it is ending at. As expected, what we are able to see is like it is 8087. Since the page numbers are starting from 0, 8087 plus 1 would be 8088. So it is pretty sure like each and every PFS page are tracking close to 8088 pages. So if we look at the pages, like as far as this particular information is concerned, what we are able to see is like pages 1 to 0 and till page 1 to 3. That is like pages 0, 1, 2, and 3 is mentioned as allocated here. So we know like a 0, page number 0 is your page header, 1 is your PFS page, page number 2 is your GAM page, and then page number 3 would be your SGAM page. So if we look at it here, we will be able to understand like which pages are allocated and which pages are all not allocated. And for the allocated pages, we can further see how much percent it is full. And also, it basically gives you the information whether these pages are part of an uniform extent or mixed extent. So that's on the PFS page. Let's check the GAM page for this particular database. So the first thing again, I'll be looking at the M underscore type, which is 8 here. So that implies M underscore type will be 8 for all the GAM pages. Yep. And then here, what I'm able to see is like we are able to see the extents here for the GAM page. And let's just pick up this one 0 and then 1:584. So what this means is like the 1:0, which is this one, it basically tells that this is the first page of the first extent in this range. And as far as 584 is concerned, this is the first page of the last extent in this range. And now if you see here, we have a value of 584, but the next line basically shows as 592. So that means like from 585 to 592, 591 pages are there. Like that is basically like refers to the last page of this extent. That is like 591, 1:591 would be the last page of this extent. So moving on, we will be able to understand which pages are allocated and which pages are not allocated. So that's the information that we will be able to see here. So all the extents within the range that, for example, let's pick up maybe this one. I think like let's pick up this one. Okay, so all the extents within the range, including the first extent and the last extent, are allocated as an are all allocated kind of. So this is the information that we are seeing here as far as the GAM page is concerned. It contains all the information about the extents and pages. So it tells us like which pages are allocated and which are not allocated. So that's the information that will be required. And moving on, let's look at the SGAM page. I'm going to run that same command, but the only difference is like I'm changing the page number to 3. So now if I look at the SGAM page, M underscore type would be 9. So that means like any page which is considered as a SGAM page will have an M underscore type of 9. So now if I look at the SGAM page information here, so again, this particular information that we are seeing, 1:0 refers to the first page of the first extent in this range, and as far as 1:182,608 basically refers to the first page of the last extent in this particular range. And what I'm seeing is like there is a as far as the value 1:182,615. So to repeat it, 1:182,615, that is the previous page to this, is the last page of this particular extent. So that's the information that is provided here. And this basically tells us, if we take this particular range, what it basically tells is like 1,182,616 is the first page of the first extent in this range, and 1:182,624 is the first page of the last extent in this range, and again 1:182,631 is the last page of this extent. So as far as this particular line is concerned, what we can imply is that all the extents within the range, including the first extent and last extent, are allocated as mixed extent or uniform extent. That's on the SGAM page. Let's try creating a new database, and then let's look at the DBCC page command. So I'm going to create a database called JBPAGE. Now what I'm going to do is like I'm going to alter this JBPAGE database, and will enable mixed page allocation on. Yep. And then what I'll do is like I will create a simple table which basically has 2 columns. One is integer and second one is a varchar 8000. And then I will be inserting only one row into that particular table. So what I'll do is like I would do a cross apply between this table, that is the one that we created, with the function Pfs cracker, and then I will basically be checking if what is the page allocation type, and also like I'll be checking what is the page number as far as this particular row is concerned. So if I run it, I'm able to see the data. File ID is 1, we know that, and page ID is 327, and is mixed page allocation is set to 1. So that means like the data, that is the pages that has come for this object is from the mixed extent. So the page number we know is 327. Let me turn on a trace flag 3604. And then what I'm going to do is like I'm going to key in the database name, file ID 1, page ID 1, which is your PFS page, and then the output print output option would be 3 for verbose. Like maybe you get good amount of information other than the other parameter. Okay, when I run this PFS page, as expected, m underscore type is 11, so we know like it's a PFS page. Now, we know that we are worried about 327, and that is where this particular row is inserted. So what I'll do is like I will directly go to that particular page and then see what can be seen there. So 327. So if we see here, what I'm able to see is like since the page starts from 0, I'm not looking at 327, I'm looking at 326. So what I'm able to see is like the PFS page basically shows that page number 327 is allocated and it is 80% full. So basically SQL Server utilizes this particular PFS page and will understand which pages are available and which pages are full, and depending upon that, understanding like whether these pages are coming from mixed extent or from the uniform extent, what it does is like it allocates those pages to the incoming object. So that's how it works. So moving on, let's look at the same one. Instead of a PFS page, I'm going to check a GAM page, which is your global allocation map page. So if I look at it here, so what I can see is like um, this particular extent, as we discussed before, 1:0 basically points that that's the first page of the first extent in this range, and then 1:336 is basically telling like it's the first page of the last extent in this range, and then 1:343 is the last page of this extent. That is not seen here, so it is implied. So now that it is like 336 and here we have 344, so the last page before this is 1:343, which is the last page of this extent. So what we can see is like we are able to see like this particular page, which is 327, which will be seen as 326 here, which is among this range, is shown as allocated. Yep. And moving on, let's look at the Sgam page. What I'm able to see, m underscore type is 9 as expected, and then here what I'm able to see is like we know that this particular range it's showing as not allocated, but if we look at this one, this is where it becomes interesting. So what I'm able to see is like 1:320, which is your first page of the last, which is the first page of your first extent in this range, and then it basically ends at 327. That is the page that we are interested, and it is basically like since the page starts with 0, we are interested in 326, but this particular range basically shows as allocated, as we know, because we have created the table and then the row is present in 327 page. Since the page starts with 0, so we can imply it as 326. So this is what we see as far as the SGAM is concerned. If I look at it one more time as far as the PFS page is concerned, we know like each PFS page keeps track of 8,088 pages. So what if I put in a value of 8088, which we know is going to be a PFS page? Let's try running that one more time. And if I run that, as expected, the m underscore type is equal to 11. And then now if I look at it here, what I'm basically able to see is like it starts at 8088, and what I'm able to see is like it is 16,175. So we know like the page number starts with 0, so that means like 16,175 will be implied as 16,176. So I'm just going to add 1 here because page number starts with 0, and then divided by 8088. And here you go. It is an a whole number. You don't see any decimal point. So that shows you that the PFS page tracks 8088 pages. That's it for this video. We will speak about memory on our next video. Thanks for watching. Have a great day. Jai Hind.